Okay, so I've got about 30 minutes, probably a bit less, in fact, to tell you about MongoDB. I could tell you lots about it, but I'm going to try and condense it all into 25 minutes. I'm going to try to tell you what it is and how you can use it. And also I'm going to tell you how it's being used in healthcare, so you can understand some of the applications that we're already seeing in the States and here in the UK as well. So hopefully by the end of it, you can tell me I've done a good job at least telling you that much. So I'm Matthew Bates. I'm solution architect. I work at MongoDB here in the UK, and I look after public sector. That includes, of course, the NHS. There's my Twitter handle, if you fancy listening to my various complaints and sometimes interesting anecdotes. Oh, louder. Okay, thank you. Okay, so what is MongoDB? Well, MongoDB is an open source document database. So rather than the rows and columns that many of us are familiar with a relational database, we're based on a document, which we'll see matches very well with the types of data we're trying to represent in healthcare, including the patient record, which we'll come to. We're open source, which means you can basically freely download us. You can freely download us and also look at our source code. So you can see exactly what we're working on now and what we're working on in the future. We're also built for the enterprise as well. So once you've actually taken MongoDB for free and you've used it, you can then actually use our enterprise version to put it into an environment where it can be trusted. And I'm going to talk a little bit more about this as well. So why build a new database, you're probably wondering. You know, databases have been around for decades. And we've got some very good databases in the form of things like Oracle and SQL Server and MySQL. Why go out and build another one? Well, the problem is relational databases aren't actually all that good at some of the problems we're trying to face today. Everyone's probably heard of big data. Everyone seems to be talking about it. We are dealing with humongous volumes of data. And actually, the technology that was built decades ago was not built for those volumes, nor was it built for those throughputs. Now, we're now seeing people needing a database to support hundreds of thousands, millions of transactions a second, things that relational databases weren't built for. So we're seeing this problem with data. We're also seeing the very fact that data is changing as well. So rather than it being very, very structured as it was in the day of COD, we're now looking at completely different data that's polymorphic, that's unstructured, that's semi-structured, and trying to build schema for that is tough. I speak of someone that's actually had to do that. It's really, really tricky. And you're constantly spending time just working on modeling your data and getting your database to work for you and not actually building a product, which is ultimately what is more important. So we're seeing this tide change. We're also seeing things being built completely differently now. So things are being built more agilely. So we want to be able to pick technology up like databases. We want to pick operating systems up. And we want to be able to very, very quickly use them to build something and to build it sooner so that we can show someone and say, is that what you meant? And if it was no, then you can go back again and iterate it very quickly. So this is quite commonly, of course, how people are working now today. And we're also seeing new architectures. Cloud computing is really becoming quite pervasive. We're seeing people use public clouds, private clouds, and hybrid clouds. And they're thinking very differently about the way they scale. And we'll come to see this in a moment. Rather than sort of scaling up, much more scaling out, which is, of course, the way Google, Facebook, Twitter all handle this very, very big problem. Okay, so what do we are? Well, as I said, we're open source. But what we try to be is a very, very fast database, and we're built for high performance. We also try to be very fully featured, because there's no good building a database that you can actually use. So as you'll see, we've got a number of features that enable us to be used without any other things around it. I'm going to take a look at this. Has anyone dealt with anything quite as hairy as this? Yeah, I don't think I've actually dealt with anything quite as bad as that, I've got to be honest, but almost. I have so many people who tell me this is what we deal with day in, day out. And we spend most of our time dealing with this. We spend most of our time actually just thinking about how this model should look and how we should tweak it. Much more time than we probably should, disproportionate amount of time. We don't believe that's the way, and this is just not the way that we can deal with data today, particularly not at scale. So in MongoDB, we have this notion of a document. Who's familiar with JSON in the audience? There's lots of hands, brilliant. So JSON, of course, now is becoming very, very widely used, very, very widely supported. And JSON effectively is sort of a set of keys and values. Those keys take the form of strings in MongoDB, and values can take a variety of different types. So what it means is that we can actually model things without any fixed schema. So in a relational database, we'd have to tell it up front exactly what our document will need to look like, or what our row, of course, will need to look like, with all the columns, with all the types. In MongoDB, we don't do that. We take JSON in the form that we provide it, or you provide it, and we can put it into the database. So what I've done here is I've shown you an example of a patient document. Now, as we know with patients, we're collecting lots and lots of different types of data. My conditions are not the same as yours. I might have allergies, but you may not. So therefore, what we're trying to structure is completely semi-structured, and we might actually need to have different types of that data. So what I've done here is I've given an example of how you might structure a couple of different patients, one of which has got a condition, which you can probably see, and also one of them also has an allergy, and we've been able to give a bit of detail to this allergy as well. We've been able to give away what type of allergy it is, what type of sensitivity, when it was reported. And the nice thing is in MongoDB, we don't have to worry about trying to define this very complicated data model up front. We actually just enable our data to evolve, and MongoDB will work with us. So what's quite nice is that we can take documents and they enable us to represent very rich and quite complex information without this challenge of having to model it up front. We've got this ability to embed. So rather than having data that you put into tables and then you have to join at some later date, which is expensive at scale, we actually have the idea of being able to embed your data inside a document. So you can probably see here, for instance, I've got an example of some observations that I've made for a patient. Of course, there are many observations, but rather than put these observations in a separate table and then have the kind of cost of joining it up later, we don't think that makes much sense. We actually think it makes sense to put it in place. And this gives real performance advantages later, not least because we can store this in the same place on disk, and we can store this on the same server. This helps us to scale later, as you'll see. And we can also make things that are polymorphic as well. We don't have to make sure that everything is of the same type. This is incredibly important when we've got this heterogeneous data which is arriving, and we don't always know what it looks like up front. And we can also change this document as well. So therefore we can add fields, we can remove fields, we can add additional items to that array there. We can grow this document accordingly. This is completely flexible. So what does this give you? Well, this gives you real agility. You can build things very, very quickly now without having to define up front what it's going to look like. You can change it on the fly as you develop your product. As you learn of a new requirement, you can just add a brand new field or remove another field. And also it gives you complete flexibility over what you store. So we think this certainly makes a lot of sense. It removes that kind of impedance mismatch that many of us are all too used to. It's also quite intuitive. If you look at that document, let's be honest, it almost looks like a patient record that we might actually have on a bit of paper. It looks a bit like a sort of typical filing cabinet where we store all those records. Pretty much the way we're doing it in MongoDB. And it also means we can scale. This is our trick. This is make sure that we can scale to the hundreds of thousands, the millions, the even tens of millions of documents and transactions. So what have we got then? We've got this JSON document model. We've got full and flexible queries. I'm going to show you some of these, say how you can actually find the data. We've got the ability to have aggregation, which I'll talk to you about. And we've got the ability to shard. I'm going to go into as many of these as I can in the time. Okay, so once we've put these documents into the database, of course the most important thing is that we need to be able to find it again. And we need to be able to find it using lots of different criteria. So much like in SQL, you can construct an ad hoc query. You can do the same thing in MongoDB. Well, this query is constructed using JSON. So not only is our data in JSON, but the queries are also constructed using JSON. So they're quite intuitive to construct. So for instance here, and it's a little bit small, so I apologize, what we've got an example of is how you could find a patient's record by ID. So nothing magic there really, much like you can do in a relational database. But we can also make queries which are a little bit more complex. So for instance here, we've got find patients that are under 18 years old with asthma as an example. So we can actually dip inside this document and we can use the various different fields inside it in an ad hoc fashion to be able to find things. Now this is with and without indexes, so we can also add indexes to make this a whole lot quicker. We can also change this document on the fly as well. So for instance, if someone was to come in and have their blood pressure taken, we want to be able to store this as an observation, and we want to be able to store this within the patient document. So therefore we've got this ability to use an in-place update to take that observation, in this case the blood pressure, the clinician who was responsible for taking that, and also the time, and put it into the database. So as you can probably see here, what I've now got is this enriched document. I've got the patient, I've got their observations, which includes that blood pressure observation, and the others that will have occurred, together with the last time this document was updated. But the difference is here, we're actually keeping this all in place, very different to how you do this in the relational world. And we can also aggregate. Now, this took me a little while to write this morning, and it's really small, so don't worry if you can't see it. But what I want to just demonstrate is that once you've got all this data, you can then start to apply analytics to it at pretty large scale. So, for instance, I've got an example here of trying to find the number of patients with hypertension with an above-average BMI in the last 6 months. And I want to be able to look at this by month as well. So you can actually construct something in MongoDB where you can sort of effectively put this data through a pipeline, and you can aggregate it in memory very, very quick over many, many servers potentially, and get an answer in almost real time. And people are using this today to build dashboards and to get real intelligence out of their data. So they're collecting this to actually create some real value. This is really quite flexible. This is something that we're seeing a lot of people using. So you've got the ability to insert data. I can change data on the fly. I can aggregate that data as well. The question always becomes, okay, this is all good. I can scale to a reasonable degree on my laptop, but what happens if I'm trying to scale to a trust, or indeed a region, or even a country? Well, MongoDB is built for scale. This is the very reason we came about. We actually were built by the co-founders of DoubleClick, which some of you might know was acquired by Google. So basically, some of their technology was used as the underpinning for their ad-serving technology. So they were built for billions of page impressions a day. This is actually back in the early 2000s. So they've kind of built MongoDB in such a way that it builds and scales and meets the kind of demands that you throw at it. And the way that works effectively is by scaling out, which is now a very common approach. Rather than taking a box and replacing it with a bigger and bigger box that's going to cost you much more, not least in power as well, you actually now sort of scale out. So you take many, many computers and distribute that problem. And actually this tends to actually much more cost effective because you can just use the resource as you need it. And it's also based on sort of much more commodity hardware, which is generally a lot cheaper. So in MongoDB, we've got this notion of taking your data and rather than just residing in one place, actually automatically splitting that data up and then distributing it across many servers. And what this gives you the ability to do is kind of aggregate all of the resource of those servers. So now you've got all of the RAM of each of those servers. You've got all of the disks which are hanging off each of those servers. So you've got the ability to write to a database that's as powerful as the aggregate of that utility. And it says you can kind of grow this as you need it. So you can start very small with a single server, and then you can kind of grow this out as you need it. So this is all good. We've got this fast database, uses JSON, which is all quite trendy at the moment. We can query the data, we can aggregate it. But actually, what about all the kind of important stuff, like data protection and failover and security? Well, this is what we've worked very, very hard on as well, because what we realize is that if you're going to use a database in enterprise, it needs to meet all of these things as well. This is really quite important. So MongoDB has something called high availability built into it. And what this means is that we can take a copy of your data and make multiple copies in different locations. You can take one server, maybe a couple, or a few, or even up to 12 servers, distribute them across a geography, and give you the ability to have those replicas almost like hot standbys, ready to kind of kick in if and when there's a failure. That failover is automatic. You don't have to get out of bed in the middle of the night. The database just kicks in and does what it needs to so that you have continued availability of your data. So this kind of helps with HA, it helps with DR, it also helps with maintenance as well, because it enables you to maintain your cluster without any downtime. Okay, so I talked a little bit about aggregation. I just wanted to show you some of the examples and ways in which we can do this. So what we've got is a very good database and good database for building out for things like for operational reasons. But we've also got the ability to aggregate. And there's a variety of ways this can be done. One of the things I showed you was this thing called aggregation framework, but we've also got MapReduce built into MongoDB, so you can use that if you're more familiar with it. And also a lot of people are quite commonly hooking up MongoDB to tools like Hadoop, where they want to be able to do sort of batch offline analytics. And we actually have connectors which are open source as well, and where people can take their data in MongoDB, collect it, shovel it out to Hadoop, do some analytics, and then bring it back into MongoDB to, for instance, maybe show kind of some analytic on a dashboard. So it's got a kind of quite a common coupling at the moment. So what I want to show you is actually, okay, this is all good, but is it actually being used in healthcare? And I want to show you some typical examples of where it is. And this is going to be a whistle-stop tour around some use cases. And if you're interested in some of them, just kind of find me. So one of the big sort of use cases here in the out in the States even, is the US Department of Veteran Affairs. And of course, someone was speaking about Vista earlier. We're actually involved in a number of their core technologies. And one of them is called the Virtual Lifetime Electronic Record. You can find out a bit more about this here. Effectively, we are sort of the data store behind that electronic health record, and it's enabling veterans who are sort of leaving the army or leaving the military as veterans to be able to share their medical record, so that when they actually do go to sort of health providers outside the military, they can actually have that medical record. So we're actually involved in this VLER, and we're also involved in this thing called the eCRUD, which doesn't sound so appealing. What it effectively is a schema-agnostic data store. So this enables them to not worry about having to almost model their data up front, but actually have a data store that they can throw data at, develop, iterate very, very quickly mobile applications, health applications, and they can then actually kind of prototype things much, much quicker. They actually got this kind of, in particular, this data store up and running within weeks. And this is now actually helping them do a lot of their modeling of their information. It's also kind of helping as well, because they've now got sort of like this consolidated data store where they can actually enforce security at that level, rather than having to enforce security at all of the different data layers. So we've got the VA using MongoDB. We're also being used as part of the Handy Halt, and if you're interested, of course the Handy is over here. So we're actually going to be really at the bottom part of it here, so maybe the less sexy part of it, but we are basically going to be the data store, which sits under a FAIR server or a FHIR server. FHIR and SMART, of course, are sort of open standards that are evolving and being adopted, and MongoDB is a really quite good fit, certainly for FHIR, which uses both JSON and XML. So if you're interested in the Handy Hop, go and find the Handy guys. This concept demonstrator is taking sort of best-of-breed open source and trying to show what you can do with all of this technology, and providing means to be able to build health applications without having to worry about all the kind of finer nuts and bolts of it, but actually just kind of use much more high-level APIs so that people can get started a lot quicker and show results sooner. So we're going to be part of the Handy Halt. Come and find me if you're a little bit more interested. We're also used for genome sequencing as well. So we've got a whole company that's dedicated to genome sequencing in the cloud. This has got 7 bridges. And they're actually using MongoDB for storing vast amounts of sequenced genomes. You can probably imagine the volumes here are absolutely huge. And they're actually using kind of the cloud to do this. They're using Amazon Web Services. Again, lots more information about this on our website, so if you want to try and find out more, please ask. And there's lots more that I probably could spend a lot more time talking about, but I haven't got time to. So yeah, we're actually being used here in the UK actually for a portal in integration providers. They're actually using MongoDB to take data from different hospital feeds and have a sort of almost like a consolidated data store, and they're using MongoDB for that. We're also being used for storing unstructured, semi-structured and structured clinical narrative. So text that's gone in natural language processed and then output in sort of a format that can then be analysed. That's based also here in the UK. We're also being used for the data store for a number of EHRs out in the States. We're also being used for sort of systems for monitoring and auditing access to patient records. And we're also being used by several large pharmaceuticals for the purposes of things like molecular similarity. So a variety of different wide use cases. And this is probably as a result of being a very general purpose database. People pick us up for a variety of different reasons. So behind MongoDB, we've got a pretty massive ecosystem. We've now got about almost 8 million downloads, and that's rapidly rising. We've also got a community around this as well. We've got lots of people using this. We've got 650 people coming to London tomorrow at a conference talking about just MongoDB. It's increasing year on year. We've got a number of people studying with us. We had 200,000 people go through our university program to learn MongoDB. So that's how in demand it is at the moment. We've got lots of people who come to our user groups. There's 35,000 of them. So you can probably see lots of different users and thousands of customers as well. So I hope you can get an idea that we're sort of a popular open source database right now. So how can you get started if you're a developer? You want to find out a bit more? Well, it's actually pretty easy because it's free and it doesn't take very long. You can actually download us and install in probably less than 2 minutes. I think probably 2 minutes is quite generous. I would probably give it, in fact, a minute. You can download us and use us on Linux, Windows, Mac OS, and Solaris. Or if you don't want to do it on your laptop, then you can just ask us to do it out in the cloud for you. So you can go and spin up an instance in Amazon Web Services, and we'll manage it for you and monitor it. It's two different options. And then once you've done that, you've got it absolutely running into probably less than a couple of minutes, you can then start using all the things that you're familiar with to start developing. Because what we don't want you to do is kind of have to worry about the nuts and bolts. We want you just to use a very simple API. So you can pick up your language of choice, Node.js, Java, Python, Ruby, Scala, Haskell even. Pick up any of those languages and just use the objects that you're already using. Python dictionaries, Ruby hashes, Java objects. And actually we kind of do the hard work of converting it to our document format, of converting it back and forth. You have to kind of worry about that. Inserts, queries, deletes, aggregations, they're all possible using the API with the driver. And then you can also use us with the likes of things like Spring and Django and Angular, Morphia, Hibernate, for instance. All of these are open source drivers that you can go ahead and use, again, without paying us a penny. But what we do have in addition to the open source version is we do have an enterprise version as well. So we've taken the open source version and we've added a number of features which make it enterprise ready so that you can go and use it. And we've got a number of organizations, in fact a growing number of organizations that are relying on MongoDB in production. Probably some names you recognize there. They're using this today in mission critical projects. We actually power gov.uk and a number of the government services at the moment that you probably are already using. So these people are relying on it because they can take advantage of its open source, community use to get started, and quite often then use some of our enterprise features for kind of added security. So for instance, we've built in the likes of Kerberos, SSL, LDAP, X509, auditing, which become absolutely essential if you've got a database in the enterprise. We've also got on-prem management. We've got on-prem backup and automation, which I'll talk about. SNMP, we've got the university which you can take on site so you can actually do training. And we've got SLA-backed 24/7 support, so we've got support teams which are around the globe which can help you if and when you need it. The MongoDB management service is both cloud and on-premise, so you can actually kind of use it in the cloud if you want. But you can also bring it on-premise so that you can manage MongoDB, you can build very large clusters, you can upgrade those clusters, you can monitor them and figure out exactly what they're doing, and you can also take backups of them as well, more at a sort of point and click. So this kind of gets you started. There's lots more information out there on the web. So we've got some downloads, which is the place to hit. We've got a blog, we've got lots of events happening and webinars. So please have a look at the URLs if you're interested in. And I'm going to be hanging around, so if you have any questions, please come and ask me how you can use MongoDB.